Good afternoon, everyone. My name is Michael Sinatra. I'm the director of the Center for Research on Digital Humanities at UWM. It's my great pleasure this afternoon, as part of our Work in Progress series from our members, to welcome Richard So from McGill University, previously at the University of Chicago. Richard started his career working on US modernism and Chinese literature with his first book called Trans-Pacific Community, America, China, and the Rise and Fall of a Cultural Network, that came out from Columbia in 2016. And more recently, he's been working in the field of cultural analytics, the application of computational and quantitative methods to the analysis of cultural, literary, and historical text. And we're very excited to hear him talk today about poetry in the age of artificial intelligence.
Hi. Thanks for coming out on this crappy day outside. I appreciate it. And hello, YouTubers, I guess, anyone watching this or will watch this in the future. I'm really grateful to be here. Thank you to Michael for inviting me. I'm truly appreciative. Yeah, it's the first time I crossed the mountain to the other side. So this is a great opportunity for me to meet colleagues, University of Montreal, and the CRIHN. I should mention that that this talk is kind of a fun talk. I should mention that I am neither a real, not really an AI practitioner per se, and I'm definitely not a poetics person. This is a bit of a side project for me where I had been talking to some colleagues in poetics at McGill, and they really wanted me to talk about machine learning and poetry. And I know a couple of things about machine learning, but I don't really know anything about poetics. But I thought it would be a fun opportunity to try to bring these things together. There is increasingly more work in this subfield. But I need that caveat to say that always the audience has more to say about the poetics part of this than I do. So looking forward to comments. Yeah, I'm just going to talk for a bit, somewhat informally. I'll work through these slides. At some point, I'm just going to stop when I feel that we've reached a kind of critical mass of interesting ideas to talk about. I won't necessarily run through the entire lecture. The lecture is actually meant to be delivered more for about 80 minutes, 80, 90 minutes. I won't torture you all by talking for 80 minutes. But this material is pretty fun and interesting, and meant to more spark general thoughts and questions about artificial intelligence and creativity. So let me just start. So here's a poem. I don't know if you can read this, but my question is this: is this poem written by a human or by a machine? A home transformed by the lightning, the balance, alcoves smother, this insatiable earth of a planet Earth. They attacked it with mechanical horns because they love you, love in fire and wind. You say, what is the time waiting for in its spring? I tell you it is waiting for your branch that flows, because you are a sweet-smelling diamond architecture that does not know why it grows. Before we start pondering this question and putting up some ideas, here are some ground clearing assumptions. So before we even try to figure out what this thing really is, I want to make clear some assumptions that would guide a query as to what would constitute a poem written by a human versus machine. My sense is that our assumptions are supported by a theory of thresholds. We're more interested in what machine can't do rather than oh, there we go. Yeah, I might have kicked it by accident. Yeah, so when we talk about machine versus human, what we're actually talking about usually is more what a machine can't do that a human can do. And in determining if something's written by a machine versus human, we're more thinking that it's because the machine can't do something that the human can do. And in the history of the scholarship, we have some prevailing ideas to this effect about what humans can do, specifically in terms of creativity and poetics, that a non-human can do. So from William Emerson, there's this idea of ambiguity and determinacy. So we generally believe that machines cannot understand ambiguity in language because they are categorical thinkers. And this is the capacity to hold two contradictory interpretations at once and to resolve such paradox is a discrete feature of human writers and thinkers and human minds. Thus, ambiguity, we would imagine, is a kind of threshold to the machine. Also, there's just this idea of aesthetic complexity, which is that computers, they need to work by rules, right? Algorithms determine what a machine does. Poetry, by contrast, right, is a representation or an enactment of language that subverts or problematizes the standard use of language. Precisely in a kind of Demonian sense, it defigures how language typically signifies, and a machine cannot do that. And last, there's this idea of a really old school romanticist notion of poetics or poetry, which is this kind of commonsensical idea that a machine cannot register affect or emotion because only humans can do that. And what in fact defines what a machine is precisely that it doesn't have emotions because only humans have emotions. And poetry seeks to produce a kind of affective register and animates a kind of human imagination. And again, by definition, these are effects that only belong to a human. Only humans have what we would say is emotion or imagination. And so we look at this poem, and we find some examples of the things that poetry scholars or poets themselves think are good, distinctive of human writing. So textually, this insatiable earth of a planet Earth, I find that to be a very interesting line of poetry that encodes a kind of ambiguity. It borders on nonsense, but in the way that it veers away from nonsense, it drifts more into poetic ambiguity. I find this bit in red, sweet-smelling diamond architecture, as a kind of aesthetic complexity. I just find that to be a kind of interesting image. You could do things with it as a critic, even though, again, it drifts towards the nonsensical, but is not completely nonsensical. And yeah, and this to me, I tell you, it is waiting for your branch that flows. This also, to me, conjures or elicits an affective or imaginative response. When I read it, I feel something in me that's moved by it. It's a very human sounding or a very affective sounding line of writing. So yeah, so there is all that. And before I give you the big reveal, let's just take one more look at this poem before I should make you pre-register your beliefs, that you could just hold them in your mind. But yeah, I flagged those bits because all those things to me signaling, this seems very human-like. But the poem was written by a machine. It was written by this fellow named Zachary Schnall, then an undergrad at Duke in 2010. He created, it wasn't quite machine learning, it had machine learning aspects. It was more driven by this Chomsky idea of context-free grammar rules. But more or less, it was an algorithm, a computational algorithm that produced this poem. So he sent the created poem to a number of journals, including the Archive, a student-run literary magazine at Duke, where he was a student, and it was accepted by the journal for publication, even though he did not tell the editors that the poem was written by a machine. And he never did actually reveal that it was written by a machine until many years later, because, quote, he felt bad and did not want the editors to feel duped. But this, of course, is an example of passing the Turing Test. So you probably know that there's this idea of the famous Turing Test, famous British computer scientist in the 1950s, devised this hypothetical test to see what would it take for an artificial intelligence to pass for a human intelligence. The test consisted of a human asking another human in a computer a series of questions, but the identity of the responder is hidden from the asker. And if the machine can provide a set of answers that can convince the asker that it is equally or more human than the human, that if it can fool the asker that it is not a machine, when in fact it is a machine, then the test has been passed. So here's basically a classic example of a machine passing the Turing test or making a machine that can pass it. So the question is, does this challenge your assumption as to how a machine works versus a human, as well as any perceived limitations of the machine? Does it challenge your assumptions as to what constitutes valid poetry or imaginative writing? And does it challenge your sense of the expressive capacities of humans in general? I find that to be more the interesting question, less the question of like, does it expand your conception of what computers can do? It's more, does it change your understanding of what humans can't do or what you thought humans could do? So this was kind of a big deal when this guy wrote this essay, I think, for when he was interviewed for Motherboard, the Vice magazine. People were really excited about it. This idea of like we made something that passed a Turing test, that's kind of a big deal. Again, though, what I find more interesting, though, is how this example of AI poetry compels us to rethink the very category of poetic authorship. What does it mean to write a poem in an age?
What is it that makes it keep going up?
I don't know. It's a good question.
It doesn't seem to be following a logical.
Yeah. Which I find really interesting.
Totally. It's the
a good day for PowerPoint.
Yeah, it's all good. I don't mind if it flickers a little bit. Right. How does it alter our sense of the poetic? And also, as a scholar, I'm not a practicing poet. I'm more of a literary scholar. How does it change how we evaluate poetry? I'm really interested in the question of how do these new forms of generating poetry change the conditions by which we analyze and talk about poetry, including defining what is poetry. The core underlying question, I think, is how does a machine create or make language poetry, and thus, I can also, and thus, how does it think or perform intelligence? To answer this question, we have to understand how AI actually works. And this would provide an account of the machine's epistemology. I think it's important to understand how the machine, quote unquote, thinks, how it can make things. And then this provides insight into the ontology of the poetry it creates. So this dual question of ontology and epistemology, I think, is really what is interesting about this little example. So I'm just going to walk through one example. The guy who made the poem used a slightly different kind of algorithm, but I'm going to walk through an example of an algorithm that is really common now in like Twitter bots, like poetry bots, things making poetry. So one way to do this is to use something called a classifier. And a classifier is really a good example because you use one, or rather your email inbox uses one every day. So you might wonder, like, how does, so every day you get spam, you might wonder, like, how does it sort the spam from the real emails, right? So literally a classifier does this work. So how does it work? So this is how it was made. So first, a computer scientist collected about 100,000 or a million, whatever, a lot of examples of real emails and a lot of examples of spam emails. It then gave those emails to a computer and asked the computer to identify differences in those categories of emails, focusing, for example, on diction, syntax, and other features. It then creates a quantitative account of these differences, what we call a language model. For instance, it will notice that the word Viagra appears 30 times more often in spam than real emails. It just quantifies. So the rules get infinitely more complex, but basically this is a very primitive, simple example of a rule that then constitutes what we call a language model. So once it has all those rules, think of it like a kind of like how a human creates a mental chart. The computer scientist then wants to test how good its rules are before it'll implement it. So then this is the key thing, what we call validation. This is the key thing. It will then give the computer 200,000 or a lot of new emails, half real, half spam, but it won't tell the machine which is which. And then it's going to ask the computer to guess which emails are spam versus real, and it's going to test how well it does. If the computer guesses the identity of these new emails, say 95% of the time, we can say that this is a pretty good language model. right? That its rules are not arbitrary. The rules are actually very effective. If it guesses less than 95% of the time, it will learn from its mistakes and devise a new set of rules. This is why machine learning is called machine learning, because the machine is actually learning from this iterative process of being tested on its rules, on its algorithm, and then improving, and then getting better accuracy as it improves with each iteration. The 95% accuracy, that's pretty arbitrary. It's whatever you determine is a satisfactory level of accuracy. And I would think for emails, like something like you want around like 99%, because if you have real emails that are labeled spam, that's pretty. So you want, again, your accuracy to be very high. But for other tasks, it can be much lower. So here is a simple example, right? So just stepping through. So this is just kind of showing the various steps, right, that I just listed, right? Yeah. So you can see the various steps that go into creating a language model that then becomes a basis for a classification exercise, and then how does it get better if it's not classifying at the rate that you want it to classify at. So to me, artificial intelligence is a misnomer to describe current computational algorithms. The machine has no autonomous, what we would call intelligence. Rather, the machine is capable of learning, not unlike a human learns. That is, a machine is given a task and improves its capacity to fulfill that task by examples, new examples, and recursive feedback. The machine is learning how to generalize about the world based on a limited sample of examples of such and such object feature of the world. So this is how the machine thinks. And here are the implications for poetic creativity. When the computer scientist asks the computer to build those rules, she and the machine are creating a language model spam email. Again, it is a set of quantified rules regarding language. What one can do next, and this is what the Duke student did, this is kind of what's interesting, is you can not only use that model to tell spam from non-spam, but you can also use it to create new spam emails because you have a language model. You literally have a model of spam language. So once you have these set of rules, you can make new things based on those rules. So if you ever wonder, like Shakespeare bot, like T.S. Eliot bot, like how did they do that? That's all he or she did, the programmer. Trained on a bunch of existing poems that are written by T.S. Eliot and a bunch of poems that are not written by T.S. Eliot, create a language model, call it the T.S. Eliot language model, and then you can use it to produce new poems that are T.S. Eliot in nature. What's interesting about the Duke student's poem is that it convinced a group of skilled human readers it was produced by a human. A certain assumption amongst humans is that anything produced by a mathematical set of rules would always produce things that lack creativity or a poetic quality. That literally a machine can only make poems or things that sound machinic in a kind of tautology. So that's like, I would say pre-AI, pre-machine learning, that was our sense. This is the intervention of machine learning. The breakthrough of ML is that you can give a machine enough data, what we call training data, and it's going to learn something about that stuff via an endless iteration of rules. And it will produce a set of rules that are not machinic in quality. That such rules, thousands of them they mimic human thought. And something that Ted Underwood and others have argued is that, and I find this very convincing, is that this really is very close to or really resembles how humans learn against machine learning. And obviously machine learning is different from human learning, but it's very, very close. It's a flexible form of epistemology. I think this is really the profound thing about artificial intelligence and machine learning today, that it encodes a flexible, fuzzy way of thinking and learning that is closer to humans than what we kind of stereotypically think about machines as really rigid, categorical thinkers. So here's my question. Can you read this poem now and identify any traces of learning, the process by which a machine slowly learns how to sound like a human? We can talk more about this later. And I have a whole second half of this talk, but I might excise that so we can talk more about this. This is actually more interesting than the second half. Furthermore, does it also make you identify hitherto disguised machinic aspects to poetic language and form, things that make it, so this is kind of the kind of counterintuitive question, right? That now that you know this poem was written by a machine, does it actually now reveal some of the latently innate machinic qualities of human written poetry that were always there, right? Otherwise, how is this machine able to fool humans, right? There has to be something inherently rules-based or machinic or mimicable in human poetry. Otherwise, you couldn't really do this. And that's sort of an interesting question, right? Like, what was it about poetry to begin with that always made it amenable to machine learning algorithms? So, in my view, the simultaneous allure and peril of thinking about poetry in the age of AI and machine learning is that it engenders new ontologies of the poetic text. That is, machine learning gives us a new angle through which to identify the poetic features that constitute a poem. That really, it is just what we call a set of features, right? Almost like a set of rules, like a mental grid. And what's troubling and uncanny about this approach is that it reveals latent qualities that blur the boundary between the human and machinic. That's the uncanny feeling. That's what I think is very interesting. That when you see a poem like the one that we just saw, again, it makes you revisit what you always thought, or it makes you problematize the things that you always thought were true about human-generated poems that previously you didn't see. It's only when you see a machine do it do you have some new questions. I have this whole second half to this talk, but I think in the interest of time and just to kind of have an interesting question, let me just flash through this. This is some work I've done with some colleagues that counts more as traditional scholarship, where basically what a lot of scholars have been doing is using this method that I just described to you to do cultural history. That once you have a language model, you can actually use it to find to find patterns in large corpora of poetry. Because once you have that language poem, you can find all of the emails that are spam-like, right? So, scholars have probably only identified maybe like 300 poems, or there are only maybe like 300 poems written by Ezra Pound, but you can train, a computer to identify a kind of Ezra Pound language model, and then you can let it, you can unleash it on, say, 20,000, all the poems written in America and England in like the 20 years, right, of modernism, and you can find all the poems that sound like Ezra Pound. And what you're doing is you're finding the literary pattern of Poundness or his influence or whatever. So that's just like one thing that I've done with some colleagues to find broader patterns, signals associated with movements, with various specific poets, whatever. You can do it however you like. I just walk through an example of that kind of scholarship. And I want to jump to the kind of conclusion that I got to. One thing that I think is interesting, both with the Duke kids poem and the scholarship now emerging, is I think they're a real pressure point for digital humanities, cultural analytics, whatever. I think what really stresses people out and what's causing so much the contention in the humanities is that what does it mean for the human practice of close reading, textual exploration, to assign a part of that work to the machine, right? That seems really stressful to a lot of people, understandably. Also for poets, right? What does it mean to allow poems written by machines to count as poetry? Like, what does it mean to open up, like an issue of like Poetry Magazine or Plowshares, and like half the poems are written by machines and half the poems are written by humans, right? It induces the same kind of anxiety or stress, right? That scholars feel in the humanities, which is, what does it mean to outsource some of our critical capacity and our labor to machines, to let machines help us do our critical or historical work. Let me skip this. I want to get to the kind of end. That's the actual language model. Let me, and there's all this stuff about Jakobson. I'm going to skip it. I really love, but we don't have to talk about Jakobson right now. It's good stuff. And I have a little polemic here about a misreading of, yeah, this is the thing that I want to end with. I think both examples really underscore this. I think the major tension moving forward in the history of our discipline, and also maybe just the history of literature and creativity, is this incommensurability between human and machine forms of cognition regarding the poetic. In the longer scholarly example I give, the real stress, the real fracture is that I would say ultimately how the machine evaluates poetry is very, very different than how a human does that, which I think is interesting and is useful leverage to potentially generate, like I think it's important that a machine has a different kind of cognition because then it can see things that we can see. And when you put that together with a human cognition, it just expands the capacity for cultural history and cultural criticism. I think that's useful. But I think, again, moving forward, this is very stressful because it erases our traditional idea of the poetic function or poetic understanding underneath the side of parsimony and efficiency. The thing that the computer is really good at is it really tends to focus on semantics, word choice. So much of like work in cultural analytics or digital humanities is very much based on semantic analysis. Often you just don't need to do syntactical analysis or even figurative analysis, which is really weird because when literary scholars analyze poems, we tend to downplay semantics and really focus on like onomatopoeia, figurative language. Machine is not very good at that. It's really good at looking at lots of words. So this is another example of the tension between how a computer analyzes poetry versus how a human does. And when you put them together, I think it's really powerful. But I do think it freaks people out that the machine can do so much with so little, it's like words. It doesn't need complicated features like narrative voice, perspective, onomatopoeia, metaphor. It just doesn't need all of that to do its work. It just needs words. And in this recent piece published in CI, this was one of the major critiques where the author who was criticizing cultural analytics says, all this new scholarship is just looking at words. And it's missing something really essential. You know, and my response would be that, well, the machine doesn't need much more beyond that. And then there's kind of this debate, like what makes literature literature? Is it more semantics? Is it more the words we use? Or is it some ineffable quality of affect, whatever, right? And I would say it's probably both. But again, the machine just really needs the words. It doesn't need to model affect or whatever. And again, I think moving forward with all this work, that tension, I think, is the real tension, both for practicing poets to be like, you know, to make a kind of interesting poem, the machine just needs words. It doesn't need feeling. It doesn't need like emotion. And similarly, for critics and historians, the efficiency and parsimony of the machine relies on a kind of disposition that's very unliterary in a sense. And a lot of people don't like that. And I think that's really one of the major tensions. If computational methods are ever going to become mainstream in the humanities, that's a concession we're going to have to make, without a doubt. Anyways, let me stop there. We can just talk. It's kind of fun to talk about this poem, which I'm going to put up again. So, you know, we can talk about ideas and arguments, or we can just talk about this poem. That's cool too. But yeah, I'm hoping for a kind of informal chat. I hope that was interesting in some sense. Let me pull up this poem.
Do you know about Raptor?
Raptor? Raptor. No, I don't know.
Have you heard of this? No. It's a poem from the early 80s, entire book that was completely machine generated.
Oh, that's fascinating.
Yeah, Christian Bach has written extensively on it. But it's like one of the earliest.
Yeah. What kind of machine made it?
I can tell you in a second.
But I'm done. Thank you.
Thank you.
Yeah. Thanks.
Thank you.
I hope that was a pleasant way to pass a late Friday afternoon.
compiled BASIC on a Z80 micro with a 64K of RAM.
Cool. Yeah, I wonder, it was probably rules-based because a lot of these machine learning algorithms are only really operable in the last 4 years. You need a certain amount of processing power.
Yeah, this was 1984.
Yeah, so probably it was like a rules-based
Yeah.
thing. Like, here are a bunch of like rules. The poem has to sound like this,
Yeah.
but that's awesome. Well, I have a question. Do those machine poems like sound like this one? Is this one better in a sense, or is it kind of the same?
I mean, it's similar to this, but my main question for you is, to what degree do certain histories of like avant-garde poetics, poetry create a condition in which this makes sense?
Right.
Like,
Yeah.
Like I read this and be like, that could, like, a lot of people would probably be like, that's possibly machine generated.
Yeah.
But for me, it's like, is it language poetry or is it machine generated?
Right.
And the history of language poetry in the late 70s and 80s makes this possible to conceive of that as a poem that is conceived of as a human for me.
Yeah, I think that literary historical perspective is super smart and a great point, right? That in order for like, what are the conditions, like the conditions by which this poem could even be legible as poetry, or dependent on a series of innovations in poetry, which themselves are fairly like technologically animated in some way. I was thinking about those crazy poems by that guy Bob Brown from the 30s. He made these machine type poems. Anyways, there is this tradition, these friends of like William Carlos Williams, right? That were very interested. Like obviously modernism itself was animated by interest in technology and so forth. That I think there is a pre-existing interface between thinking about the technological capacities of language and vice versa, right? That created a kind of aesthetic that then you see like in like language poetry, whatever. That's a prehistory for this to be legible as a poem. Yeah, that'd be like a cool thing to like kind of work out, right?
The thing that I was imagining that would be really interesting to do is to actually like put it back into a kind of machine learning model and to be like, you put 40 Jackson McLowe poems and then you put 400 language poetry poems, and then you take the entire Raptors, Nick Montfort's entire AI model kind of poems, and put them into a single database and get literary scholars, students, etc., to try to identify. And it'd just be interesting to see which ones end up becoming, which ones humans think of as being machines and which ones are humans.
I love the idea of like training on a bunch of poems that are already like machine. Yeah, that's a great idea. It gets to this also like the kind of counterintuitive idea that I'd be interested. I don't know enough about language poetry or the avant-garde, but a lot of the things that people fault this kind of poetry for, like it seems that some of those qualities are actually valorized in other traditions, like language poetry seems to me very semantic in some ways, right? It's very interested in like single words, very much in the way that people fault, like what we call bag of words. So a bag of words model is just looking at words, and that's what the language model relies on. And people are like, that's not poetry, that's just like semantics. But it seems that there are traditions of poetic discourse that are very like semantic or like, very bag of words in nature.
The other tradition is flarf.
Which
is like another really important, like late 90s, early 2000s American school that is just like, we have the internet. It's like language poetry and being like, we have the internet now.
Right.
What does this mean for the composition of poems?
Yeah.
So it's just interesting to think of this as like a continuum with like coming from Fluxus language, flarf. And then like situating it. What happens when you think of this kind of form of composition as necessarily part of a continuum that involves these?
Yeah, that's totally brilliant. Yeah, and Jasper Burns has written on flarf, right? Yeah, I think I should play that. Yeah. Oh, he's a great guy. He's an awesome guy. Yeah. Cool. Yeah. Thank you for that. Yeah. Questions?
You were speaking about language model that you are producing for the analysis and that allows you to categorize.
Yes.
What striking me is I'm working in art history field, and we have the same issue about works of art produced by the machine, and also image analysis, which is brand new in art history, because with machine learning, and especially with deep learning, currently it's possible to analyze image. But I was wondering about the status of this model, because I think it's quite different than what we are used to with a language model, where we have something which is processable quite easily. Text is a text string, and you can objectivate. It's possible to make some objective assertion about the relation between the serial relation between these elements in the string. And for image analysis, I think the issue is much more complicated. I'm thinking a lot about what could be the status of this
the
status of the model we are producing. The status.
Status.
Yeah, status.
Oh, status. Okay.
That's my accent.
So I don't mind listening here.
How much could that be useful in the research process? Because it's all obviously it's often considered like something coming out from a black box.
Right. Yeah.
I think it's quite different for the language model. But can you elaborate?
Yeah. And you know, at your university, you have like the best deep learning people like in the world. So that's very cool. Yeah, you know, for a lot of us in working on text, and I agree, it's much more complicated when you're doing image processing and also sound processing. But we tend to when I say we, other people in cultural analytics in this sort of emerging field, we tend to avoid using models that are excessively black box or complicated. So a lot of deep learning algorithms like decision trees, neural nets, they just are too opaque. Like it is truly a black box. Even computer scientists don't fully understand how they work. We tend to use much simpler models where, for example, we use something called a logistic regression classifier, where you can see the contribution of every feature. So pretty much at every step, you really understand how the model is working. So because to me, like in the humanities, you should use kind of simple, cruder models, because the goal is not for perfect accuracy. Like I think in the medical field, right, or biology, you want the most powerful models. You don't really care how they work. Like if it predicts cancer 99% of the time, like that's good. Like I don't really care how that model works, right? You care about its efficiency, its accuracy. To me, the humanities, though, what we call interpretability is much more important, right? Whereas you could build, a model, a neural network model that can distinguish like Monet from Van Gogh like 99% of the time, but it's like, who cares, right? Like that's ultimately not that important. If you don't understand how the model works, that model is not that meaningful to humans.
That's my point, in fact. And for image analysis, you don't have other issues, because we can't use vector matrix for words and all this.
Right. Yeah. Exactly. Right.
And so we have to deal with this opacity. We have to deal with this unknowledgeable model.
Yeah.
So I'm asking myself what is the ontological status of this model in the research process? And
I understand your question. Yeah.
How we can mobilize them or produce them for an analysis, even with their complexity and things we don't know about that. Because we can train a model, produce a model, and then evaluate how it fits with another context. So in a way, it can be a medium thing. We can work with, but I don't know if it has been done in textual.
So the method we're pushing, so a group of us in cultural analytics, we push this method called literary modeling, which is exactly what you're describing. Like we make these models, but they're always being checked and validated against close reading. Every part of the model we investigate. So nothing is black box pretty much. And every part of the model is being recursively changed based on the validation of that close reading. So it's really mediating between distant reading and close reading, where you're constantly changing the parameters of the model to better suit the goals of your analysis. And I think that has to be the way forward for the humanities, and that we just can't use the most cutting edge, crazy, most powerful deep, because you can't interpret them. Again, it's not useful for the humanities. Whereas in in literary studies, we tend to again use simpler models with simpler metrics, but you can control them more. So like everything down to like the variable selection, analysis of variance, like everything about it we understand is always being tested against close reading, but also like critical theory, like theories of the text, existing scholarship. So there's a lot of dialogue between existing research and the model that you're trying to build. But I think like the goal is to actually, like I think the temptation in the beginning of DH was, let's use the most powerful models. I think that's actually not the right idea. I think you should use actually crude, simple models, as long as you can understand how they work. It's not a black box. So, yeah. Questions?
I have I don't know if it's a relevant question, but I just asking myself about the kind of random fact, and because some of with the language model, some of the author are just not fitting with one style, or their style just evolving during the year. So it's my question is the machine, does the machine interpret kind of random fact as or the kind of disorganization as a new one, or another organization? Or does she just drop it out?
Yeah, interesting. Yeah, no, I understand your question. And this actually gets to, I'm sorry, what's your name again? So, Emmanuel. Yeah, it gets to your question too, right? That models are meant to generalize about lots of data, right? Your question is like, if you create like a language model for Goethe, like, that there's a lot of variance, right? That early Goethe is really different from later Goethe. Apparently, I'm not a Goethe specialist. My colleague, Andrew Piper, is. Again, these models come from the sciences, right? So there's lots of variance in humans. So if you're trying to detect cancer, right? You smooth out the variance of different humans, because who cares? You're just trying to cure cancer for as many people. You're trying to do something different though for the humanities. And so it's really important to, when you're building this model, like this Goethe model, right? You might find that the model generalizes pretty well, except there's one outlier, right? There might be like one story about Goethe that doesn't fit the model, right? And to Manuel's question, point, right? The sciences would just ignore that. They call it an outlier, and they remove it from the data set. It's like what they call noise, right? I think humanists should do something different, right? That you could privilege that outlier and like reconstruct the model around that outlier. It's like in cancer research, why would you do that, right? There's one person, the drug didn't work, but it works for like a million other people. You don't kind of care about that outlier, right? It just sucks for that person, right? But in the humanities, like with literary text or artistic text, you might really care about that outlier, right? So what we would do, right, is what we call leverage, right? The statistical term like leverage, where we really look at that one text. If it's very important, we actually reconstitute the model, right, or to accommodate that example, right? And the model changes. So this is what I mean by you have to know how the model works to do things like that. And that's that kind of recursive, what we call literary modeling, that recursive process of looking at like close reading the material, changing the model if necessary. But it's just hard because modeling is a generalized phenomenon. There's always going to be interesting outliers. It's like, what weight do you put on that? I don't know, right? But there's always a way to check for this, right? Like a model should not have too much variance, right? If the model has too much variance, maybe what you're modeling is maybe like 4 different things, not just 2 things. But again, this means really knowing your material really well, but also knowing your model really well, and putting those 2 things together to come up with a model that actually makes sense for the question we're interested in. Yeah. So either way.
And could a machine support like contradiction?
Of course, yeah. It depends what you want to do. You could, either you can create a model where it smooths out that contradiction, or you could build a model that actually accentuates a contradiction. Right? You could have a model that actually looks for or like is trying to understand the nature of that contradiction. You can do whatever you want. But again, it comes down to your research question and your ability to manipulate the model, which again goes down to like, if the model's too complicated, you can't do that, and then the model's kind of useless, but it's got to do what you want it to do.
Would it be possible to just, I don't know, because when you talk about the authors, one author style.
Yeah.
It could be many styles.
Yeah,
just
exactly.
One
Yeah.
name.
Right.
So are you just thinking about create like I don't know a language model which gathers many language model of
Yeah. You could do that too. Yeah, I mean, like, you can, what we like to do is like, on a single corpus, run different language models. You could do that and see. I just think like there's a lot of room for creativity that's somewhat absent in the sciences, because in the sciences, they're really trying to solve very specific problems, right? And there, you're just looking for efficiency and performance, right? I think in the humanities, we're looking for something different, which is the widest range of interesting interpretations, right? So like a cancer researcher would never like, try 4 different models and kind of compare them and kind of come up with interesting interpretations. It just would pick the best model that like detects cancer. Like, why would you use, what we do in the in this kind of literary modeling stuff, sometimes we optimize our models to find error, to actually find the wrong things, because sometimes error can teach you interesting things. When the machine gets confused, that could be really interesting, because genres of writing often are really ambiguous, right? And sometimes when the machine fails, what it's telling you is that this genre is just really complicated, right? So sometimes we try to maximize error in the machine, which again, you would never do in the sciences. You would never maximize, detecting errors like, detecting cancer. That's crazy. But the humanities, we're looking for something else, right? So I think you can do a lot of cool creative things that we're just really at the beginning of exploring and understanding. Yeah.
I was coming back to this complicated model, because in a way, the question you addressed when you were showing machine-made poetry, and especially the new one you can make with this deep learning algorithm, which are much more smoother, maybe, and deciphered, which are much more difficult to distinguish from the other. I think if we are confronted to such texts which are made by machine learning, but also deep learning system, we have to consider the way we could analyze them with the algorithms that produce them. And not only with the one we can work with easily, because they are quite known and documented, including a very strict process. J'ai l'impression qu'on va être obligé de s'en occuper. In a way, I think we have to think about which place they are taking part in the game now. Even if I can understand that we focus firstly our work on things we could control.
Yeah, I agree. It's interesting, right? I mean, like, it's a question of like, what can we really understand in the end? I mean, like, I do have concerns, that a lot of people have concerns that a lot of the new algorithms are so complex, like it's almost impossible to understand them.
Even though they are not so complex, it's strange. When you look after the formula they are using, it's quite not so complex. The complexity is coming from the construction of the decision tree.
Yeah. I agree. I mean, it's just kind of like retracing the millions of like, neurons firing that led to that decision. That's really complicated. I agree. The actual like math behind it, it's just often just like logistic regression. It's really quite simple. But it is the kind of million decisions that are almost impossible to reconstruct, right? That's very difficult. But yeah, to your other point though, I agree. Like we have to.
What makes a model is not the fact that we can regress from it, but more the fact that the model is a representation of.
Yeah, that's right.
Something.
Yeah, that's right.
So in a way, can stay as a model. Work with the model.
Yeah.
The model, like something we can refer to.
Yeah, I agree. Yeah, I guess for me the only distinction is like the modeling aspect and then the computational aspects, because a lot of the the computing behind it is often quite enormous and vast. Yeah, but I agree. The actual model is often simple, reducible to equations. Like humans can really understand that. I have more concerns around the vast architecture of the data processing, the computing, which is often quite vast and very hard to understand. So to me, there is a distinction between the computer science and the statistics part of it. Yeah.
I wonder whether I'm just trying to see whether looking at reviews from early 20th century poetry, did they complain about the kind of machinistic, style? I mean, I'm just thinking about like the poor reception of these innovative, whether it's doing it with punctuation, whether it's doing that. So whether there'd be an interesting parallel between the reaction in the early 20th century, that kind of poetry that felt cold, artificial, and mechanic in a way, or even some of the experiments that were made fun of with like do you remember now about that group of French poets there? It was like you write a word, I write So all these constraints, all the playfulness of
procedural works historically from the 20th century.
Yeah, and that kind of reception as being kind of either obviously anti-poetic in the first place with a legacy of the 19th century image of what sound and rhyme and all that. But more specifically, whether there was, because of that kind of early kind of reaction to the mechanization of process, whether we already had that sense of it feels like it's written by robots were already very much in the kind of popular imagination with the late 19th century sci-fi explosion. So that idea of is this what the future will be, this nonsensical poem that in some ways, I mean, I was obviously thinking about that because I had a glimpse of I felt War of the Worlds, like they attacked it with mechanical horns. I just had that sense of somebody who's a bit too much of a H.G. Wells fan. But yeah, so and then whether if we were to look at a whole range of these reviews, whether these terms actually come up or
that'd be such a cool extension of this. I mean, that'd be really interesting, to look at the reviews and try to understand like that language, right? Whether they're anticipating. I don't know. I mean, I think you would know more about this history.
Yeah. Well, it's. I mean, it just leads to the question: how has there been a discussion in developing this with you and the people that you've been working with in this to like enter into literary historical models? And what if not to include that into the frame of this kind of research, why not? Which I'm not saying that necessarily you should, you know what I mean? But I'm interested in why not to include that.
Yeah. We do in the published version of the essay. We do a little bit about that. We get a little bit into the intellectual history. Some Dada poets that were literally referring to how they write poems as a bag of words. And so, bag of words is like this computational term that. That's how the semantics work. So we do a little about that. I think more and more people. So more people are doing this. There's a great piece by Michael Gavin on this method called word of Beck, and he's looking at like MSIM, like kind of like this prehistory of thinking about collocations and like semantics of meaning and stuff like that. So I think there's more work. So this piece is really great by Michael Gavin, Critical Inquiry. It was weird because, when we were doing this work, we just chose modernism because the data was easy to get. We're not really modernists. So we did less of this. And, it's just sort of like to generate some work that other people can follow up on. My period is more like post-war American novels, stuff like that. So I do more of that kind of thinking around that. But it's interesting, it is one vector of new work that should happen that some people more like this guy, Michael Gavin's interested. Because, some people, they're really excited about these new methods and they just want to write new literary histories that are not necessarily reflexive. They just want to get to the work of like proving things. I'm a little bit more in that camp. And then there's other people like this guy Gavin and some other colleagues that are trying to do the more reflexive intellectual history work. I think it's all awesome. Like critical theory in the early 80s, like there was Barbara Johnson, there was like everyone's just, I think it's like you're right. There's so many ways to approach this question. And I think I'm better at just applying the models, but I think other people are better at these intellectual historical questions. And definitely check out this guy's work, Michael Gavin, because he's really interested in the history of criticism plus this kind of stuff.
Because there is a total history from William Carlos Williams talking about how poems are machines made of words.
Exactly.
And being criticized for imbuing that poetic into his work to flarf poetry be
Yeah.
absolutely disdained because of people actually do think it's a spam.
Right. Yeah. Totally.
As a poem and things like that. And so it'd be interesting to.
Yes, someone should do it. Yeah, you're a student. You should like I'm just one person. I was. Yeah, it's funny presenting this stuff because I just feel like all these people in the audience have better ideas to push us further. I did this more as a favor to some colleagues, but yeah, it's so rich. I think around poetry specifically, because of its long tradition of a kind of pattern-based discourse. But
So that's great. Well, thanks again, Richard, for the talk and the conversations.
Yeah, thank you. Thank you for having me.
Really cool.